Hello, welcome. In this part of the video lecture, as a part of Programming for Problem Solving Lab, I, Sandhya, will take you through the Lab Task 3A. What is Lab Task 3A? Here, we are supposed to find out the roots of a quadratic equation using if-else. Or here, we'll take the example of an else-if ladder and try to find out the roots of a quadratic equation. What do we know about the roots of a quadratic equation? We all know that the roots of a quadratic equation ax square plus bx plus c is into three types. They are real and equal if that is zero, discriminant is zero. They are, real, distinct and unequal, distinct and real if the data is greater than zero, and imaginary if the discriminant is less than zero. So what is discriminant? It is b square minus 4ac, right? So therefore, we will now see how do we run that program. Okay, so let's go ahead and see. Here is a particular, program, LabTask 3A. I'm using a Turbo C editor in which you are writing a program to find the roots of a quadratic equation. So therefore, here there are three variables A, B, and C, which are all float. You can take it as integers and later convert them into, use typecasting. But for general simplicity, we took off as float ABC. There are two roots, root 1 and root 2, but the roots may be imaginary as well. So there is something called as imaginary. I'm reading A, B, C, the coefficients of all the three variables, then followed by calculating the discriminant. So how do you tend to calculate the discriminant? Discriminant is b square minus 4ac. You may or may not have braces here. That's clearly optional. B into B minus 4 into A into C. So this is the discriminant. After discriminant, there are three conditions. So I have used an else if ladder here. So if discriminant greater than 0 implies that the roots are two distinct roots which are real. We know that there are two distinct real roots for this equation, which is calculated by minus b plus square root of d by 2a minus b minus square root of d by 2a, where d is discriminant. So this is something like that. We used a predefined function sqrt of mat.h. And then 2 by a must be enclosed in braces, otherwise by 2 into a will happen. So therefore, to ensure and preserve that particular truthness of the expression, you have to put 2a inside braces. Okay, so here that's how you calculate your real and distinct roots. Then if your discriminant is equal to 0, we all know that the roots are real and equal. So therefore, root 1 is equal to root 2 is equal. This is multiple assignments. You can assign a single value to multiple variables like this. A is equal to B is equal to C is equal to D is equal to 0. That also can be done. This is multiple assignments. Minus B by 2A. 2 into A again under brackets. Okay, so here you calculate. Now the toughest part of this calculation comes for all the students, where we keep on encountering issues and errors, is when we are talking about imaginary roots calculation. So yes, imaginary roots need to be printed by us. So therefore, we all know that minus b by 2a is the real part, and under root minus d by 2a is the imaginary part. Why do we write under root minus d? Because discriminant is less than 0, it's a negative value, and you can't find out the square root for a negative value. So therefore, what do we write? We'll find out square root of minus discriminant. Please just note the change. It's not square root of discriminant unlike the other two cases. It is minus discriminant because we are making the negative number positive and then adding the imaginary part before. How do I print the roots? Root printing is pretty simple here. We know that the complex roots are of the type a plus ib and a minus ib. Since there is no solid method of printing a plus ib type data type available, we directly print real part plus I. Please make a note, I imaginary part. Real part plus I imaginary part. And again for root 2 also we'll do the same way. Real part, that is percentile 0.2f, minus I imaginary part. Now, what does this percentile 0.2f mean? As we have seen in managing input output, percentile 0.2f prints the exact fractional part only up to 2 decimals. It only prints up to 2 decimals, because in general float prints up to 6 decimals. That might or might not be relevant for us. So therefore, we are just limiting ourselves to printing 2 digits after the decimal point. So here is my program after else if. This is already discussed in else if ladder, that writing an else is your optional. Here you can write simply else and avoid this condition, or you can write else if and put the condition and just leave else part. That's up to us. So return 0 because we have used int main. Let's compile the program, save the code once, compile, alt F9, run. When we run the program, it's asking me to enter A, B, C values. So my dear students, please try to calculate on a pen and a paper. Take a minute's time and calculate what is the roots if my inputs are 1, minus 5 and 6. What is the roots if my inputs are 1, minus 5 and 6? Hope you're ready with the answer. Yes, the roots are real and distinct. You know, the roots are distinct and real roots, they are 3 and 2. Yes, 1 minus 5, 6 is an expression whose roots are 3 and 2. Got it? This is how you can see. Okay, let's again run the program for another set of inputs. So now again take your pen and a paper and let me know what is the output when your input is 1, minus 8 and 16. Calculate. Calculate by taking the formula 1, minus 8 and 16. What did you get? Yes, you got two equal and real roots, that is 4 and 4. Root 1 is 4 and root 2 is 4. Exactly. So let's again do it for some imaginary roots. Okay, 1, 2 and 3. Yes, here it is. These are, okay, sorry. Yeah, these are my imaginary roots. Minus 1 plus I 1.41 and minus 1 minus I 1.41. Okay, so this is how we can execute all the three possible cases. And this is how all of us can get to, can get to implementing the roots of a quadratic equation. Okay, so take time, try to do it yourself and try testing all the possible cases. Good day.